Good morning, all of you, my dear students. Today, we'll discuss about the topics of sensors and transducers types, displacement, position, proximity. Right. And then before that, we will discuss previous topic summaries. So last class, we discussed about control systems, classification of control systems, open loop and closed loop system. In open loop system, there is no back element, whereas in the closed loop, feedback element is there. In the open loop, we cannot get our desired output. Here, the output in the loop is followed, not the input variable. Whereas in the case of the closed variable means output, that is the desired output, that is our required output. Here, output is dependent on the input variable. Whatever input value you set in the closed loop control system, that is the same reflected in the output without any error. That means accurate value. I told to you the example of our AC air conditioner. When you set the temperature 18 degrees centigrade means total the room will be connected to the 18 degrees centigrade within a small period of time. That means this is the thing in the closed loop control system. That means in other words, we can also in automatic control system. And then next, what discussed about the advantages and disadvantages of mechatronic system. And also we discussed in the last class about microprocessor based all machines, oven, dishwasher, and ATMs, and in the manufacturing process control, computer numerical control. These are all computer based. These are all based on this microprocessor based controllers. So there are so many examples there. For example, see here the microprocessor here in this the playing a major role. That is with the help of the keyboard and we have to set the desired value, and then it will be displayed in the display board, and then you have to switch on. For example, take the washing machine. In that mode, it is in the display it appears. You have to set time as well as you have to set mode, all the things we have to set it. That means with the help of the keyboard which is on the washing machine, you have to set the keyboard whatever the desired you need. So like this, these are all the things. So here the microprocessor based controller. Almost all automatic systems are microprocessor based control. That means here a mechanical system, that is a washing machine, is integrated with computer based information system, is integrated with computer based information, and also electrical sensors. Here in the washing machine a drum is there, right? Here the drum rotates, so that is with the help of the motor. So all electrical, all these are mingled. These are somebody said that voice now it is clear. Now it is clear. Voice cut out, sir, and somebody said. So, now it is clear. Okay, okay, okay. Thank you, thank you. Sir, okay, okay. Right. Uh, then we discussed about the advantages and the disadvantages of mechatronic systems. Sir, advantages are more in this case. Advantages. That means we can get the correct accurate value, and then the production also we can get a more within a lesser period of time. like this. For example, some disadvantages are there. For example, if you take in the washing machine, we are placing clothes inside, and then it undergoes rinsing, and then we cannot just we will set the output mode, that is slow rinsing, fast rinsing, or medium rinsing, and some period of time. But we cannot justify whether the clothes are clean up to your mark or not. So that type of disadvantages are there. That type of disadvantages. That is the thing. We cannot justify it. We cannot justify whether the cloth is up to the mark. It is cleaned according to your satisfaction. We cannot justify it. That type of disadvantages are there. But in sometimes we can get the output correctly. For example, take the ATM machine. If you press the whatever you are required amount, for example, 1,000 rupees means the ATM machine will hand over to you 1,000 rupees only correctly. Sometimes maybe some minor errors are there, maybe 1%. Sometimes the money will not get. So if you approach the bank, there the persons will rectify the problem. Like that, small minimum errors are there. So that is a small disadvantages are there. And then the skilled person required to clarify that ATM, whatever the problem inside, it is there. So like that, some small disadvantages in these microprocessor-based controllers. But advantages are more. Almost all 98 percentage it will work so properly. The any mechatronic system, 98% compared to that manual system. This mechatronics automatic system is almost all 98% work correctly. Now today's topic, we'll go for today's topic. It is audible. So one person I will just unmute. You just speak number 352. 352. Number 352. 352. Please talk. I unmuted you. 352. 352. Please unmute yourself. 352. Whether you are there or not. Message in chat box. 352. I hope so. He is not there. 352. Number 352. He is not there. And 301. 301. You are there. 301. Yes. Okay. Just unmute yourself. Talk. 301. Ah, 301.
Yes, sir.
Hello. Please talk. It is audible to you.
Yes, sir.
Okay. Whatever, my voice is clear to you, right?
Yes. Yes, sir.
Sure. Right. If there is
Yes.
any disturbance, I request to all my students, you better post in the chat box. I am observing, so you can clarify immediately. Great. Okay, 301. Okay. Thanks. And then today's topic, we will discuss about the sensors and transducer types, displacement, position, proximity sensors. Today we will discuss these topics. Sensor. Sensor is nothing but it is one of the device that it detects the physical variable from the environment. Physical variable or physical quantity or some parameter who will that it will detect from the environment. And example, there are so many examples are there. That is, for example, take our ear. Ear is a sensor, skin is a sensor, and nose is a sensor, tongue is a sensor. These are all sensors. these are all sensors. Here in the example, in the slide, it is written that thermocouple is used as a temperature sensor. That means thermocouple measures the physical parameter temperature. Physical parameter temperature. And then there are so many examples, sir. Brain, sir, some that brain, Harshvardhan, 312, lateral. So a brain is a transducer. That means it converts one form of energy to the another form. Here the brain translates one form to the other form. So here the transducer, here I written transducer is a device. It receives energy in one form and then it converts to the another convenient form. That means our required form. That is our required form. And then next, in the transducer, there is so many examples are there: capacitive transducer, analog to digital converter, and digital to analog converter. There are so many transducers are there. Right, engine it converts one form of energy to the other form. That means here one body written. 1 minute, please. Here the engine converts one form of energy into the another. That means here it receives chemical, that means fuel chemical energy, and then it converts into mechanical energy. Take motor, electrical energy into the mechanical energy. So these are all the things. There are so many transducers. That means a transducer is nothing but it converts one form of energy into the another form of energy. Then we'll go for the next slide. And the displacement, proximity, displacement position and proximity sensors. Displacement. This is, if you see the displacement sensor, position sensor and proximity sensor. Displacement is nothing but how much amount displaced by the object. That is called that how much amount displaced by the object. That is nothing but that detection is nothing but a displacement displacement sensor. And in the position sensor, these position sensor it finds the position of object. It finds the position of the object with reference to the some other point. That is the position sensor. Whereas the proximity sensor, that means the object is moved by some particular distance to the sensor. That is called proximity sensor. So again, I'm repeating, all of you listen carefully. Displacement sensor is nothing but it measures the distance moved by the object. Distance moved by the object. And the position sensor, it finds the position of the object, and that means or the location of the object with a reference to the some other point. Proximity sensors is nothing but the object is moved to some particular distances to the some object. That means it moves only some particular distance only, some particular distance. Proximity sensor. Somebody said that digital vernier calipers, right? Digital vernier, right? It moves correct, right? Very good. That is some particular distance only. Letter entry number 6, message in the chat box, right? Then proximity sensors are nothing but example. If you see the proximity sensor, that is nothing but our switches, on and off switches. On and off switches. That means when you on the switch, for example, when I have to on the bar light or the fan, when you on, that means that switch when I touch, it moves some particular distance only, some particular distance, and then it will contact whenever I push the button with some force, that means that button will move some distances towards, it will contact to another one, thereby the light glows or fan revolves. So all proximity sensors are nothing but on-off devices, proximity switches. In this proximity switches, there are two types: contact type. Last somebody message in the chat box. Three to last class. So, doubt unda anna. Somebody 323. So last I will discuss whether at the end of the class I will give some time and then you can go for doubts. Okay, right? One person message in the chat box that the last class is having doubt. Okay, right? Very good. And then we will discuss at the end of this class, right? The next here, proximity sensors are of two types. One is contact type and the other one is non-contact type. Contact type means when you push the button, when you have to switch on, that is to the button. Some switches are there without external force, automatically it is on and off. Those are called non-contact type of sensors. That means non-contact type of switches. That means, for example, if you see one movie, Avunu, I hope so all members know very well, Avunu cinema. In that, one person, if he went to one room, for example, maybe living room, automatically the light will glow and the fan will revolve, the rotate. Right or wrong? Correct. Fan will rotate. When you come out from the room, automatically the whatever the uh, light and bulb and whatever the things, fan will be automatically off. So these are non-contact type of sensors. That means there are so many things like that. Those are the switches, only switches only. That means it on and off. And for example, if you go to any restaurants, automatically when you place the hand in, if you go to hand wash, if you place the hand nearer to the tap, automatically it will on. Automatically the water falls from the tap. So these are all non-contact type of sensors. That means non-contact type of sensors means the object is the object is very nearer to that distance. That means some constrained distance only it will respond. Otherwise, it will not respond. Remember this point. In a proximity non-contact type of sensors, major this non-contact type of sensors are used in industries, wide range of industries, wide range. That means with some distance only, some particular distance only, it will respond. Otherwise, it will not respond. So that is here I written clearly some particular critical distance, some particular critical distance. These are non-contact type of sensors, right? And contact type of also you have to push the button only some particular distance only, and then it will contact and then it will respond. For example, take our iron box, right? Automatic iron box. Inside, what is there here? Bimetallic material strip is there. Here, when it is heated, automatically it will expand in a circular. It will expand in a circular. That means it will expand like this. The bimetallic strip is like this. This is the first material, and this is the second material. This is the first material, right? Uh, I'm drawing this is the first one, and this is the second one in the bimetallic strip. Here, when it is automatically overheat, automatically this bimetallic strip will bend like this. Expansion. That means the thermal expansion is there. It will expand like this. It will expand like this. It will move like this. And then here one contact is there. When it touches, automatically the switch is off. And it will not touch it here. Like this, automatically it will touch contact is there, automatically it respond. Iron box will off. Return chat box. Tracking mobile from single push. Right, correct, right, very good. So like this. So now we will discuss one sensor. Here, displacement, position, and proximity sensors. Here, when selecting these sensor, it is essentially some we have to take care. That is the size of displacement, nature of the displacement. That means nature of the displacement, whether it is a linear or angular, and the required resolution and accuracy, the material of the measured object. Material is very important thing. So some magical materials are there. Here the material playing a major role in the sensor. Magical material. That means that material will respond with some parameters, maybe temperature or maybe some other humidity, like that. Automatically, the material will respond. For example, small force. That means for some particular material, if small force is exerted, automatically it will respond. The output should be more. Like that, here the material is playing a major role here in this sensors. That is, in other words, we can also call it a smart material, right? And cost. These are the while selecting a sensor, these are the considerations we have to consider. This material is very important, right? Material very important in this sensor. Any sensor, material is very important. We can call it as a material is nothing but smart material, magical materials, like that. We'll go for the next slide, and we'll discuss about the displacement sensor and position and proximity. These are all the same pattern. Potentiometer, potentiometer sensor. So now I will discuss one thing, one important thing to you about a DXC training. That is DXC. I hope the section A knows very well. Here, one Google form sent last night. So those who are eligible for DXC training, you have to fill that Google form. So day by day, see here the COVID is increasing. For mechanical, it's very difficult. So consider my words, and then we have to train in that training, DXC training, and then you have to acquire a job. Then only you can life will be grows. So why? Because I am telling all the things. Maybe for mechanical core, it's a very somewhat complicated to get a job in this situation. So my advice, my opinion. So consider my words, my dear students. Those who are eligible for DXC, they have to fill the Google form, and then after filling the Google form, you have to pay 1200 rupees, uh, and then by you are getting the receipt, and then receipt again you have to fill another one Google form they will send. So this is actually 14 days training program, 42 hours daily, 3 hours. So maybe in the next month you are having exam. So you have to concentrate much more on this. So my request to all the students, those who are eligible for DXC. So better in this afternoon, before afternoon. that is before 1 p.m. you have to fill the Google form. Then so don't think in other way, that is this is a software, sir, whether we will get or not, it will be further it is useful to us, like that. Don't think like that. So here it is a very good one, a multinational company, and then if you train in that one, if you get job, is that is your life will be succeed. So think, huh? And then you have to fill the Google form. So day by day it is very difficult. So remember this point, my dear mechanical students. Maybe we can't expect whether in the next year you can get the mechanical core placements. We can't say. The situation is completely different. So you have to understand my words, and then consider my words, and then whatever the opportunity comes in front of you, you have to utilize it completely. You have to utilize it completely. That is the target. You have to place the target. So here, once if you get the job in this DXC is a very good multinational company. So then your life will be settled. So you have to think, and then you have to fill the Google form. Just now, recently I checked, around 8 members only filled. The remaining members, around 50 students, are eligible. So consider my words, all 50 students has to register in DXC, right? And then 14 days training program it is. 14 days, 42 hours it is, every day 3 hours. And every day after 3 hours training, you are having some exams are there. And then the results will be displayed every day. And then there are so many persons are there, they will guide you, and then you can clear the doubts also. Okay, right? You understand? Understand or not? Any one of the person can post the message. I'm expecting positive from you. I'm expecting positive from you. Anyone? Section ACR. How to explain section ACR? Section ACR. Section ACR. Anyone? $44. Sundar, you are here? Nagaraj is there? You're not responding. 380. Raj. Okay, right. Okay. So you have to consider my words. This is very useful to you, and then you can apply for that, right? Huh? And then you can benefit much more. So that is the thing what I have to tell you regarding this DXC, right? The next, come to the lesson in the potentiometer sensor. Potentiometer sensor. This is, see here in the potentiometer. This is a slider. This is a slider. This is slider, right? And this is the resistance element. Resistance element. Here the slider moves on the resistance element. This is a resistance element, and this is a slider. This is a slider, right? This is a slider. When this slider moves or slides on the resistance element, there will be a change in the resistance. There will be a change in the resistance. Once there will be change in the resistance, automatically the voltage may vary. The voltage may vary. That means here displacement sensor. That means this slider displaces. That means maybe from left to right or right to left, like this. Uh, Automatically, when it moves, the resistance changes. Once the resistance changes, the output voltage varies. The output voltage varies. The output voltage varies. Are you getting my voice? Just I am testing. Any one of you can respond. Yes. Okay. 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 Then next, see here. This is here. What parameter is changing here? Output voltage is output voltage is changed. Here, when the slider moves on the resist, that means some distance it is displayed, or it changes the position. Automatically, what happens? There will be a change in the resistance developed. That in turn, there will be a change in the voltage. There will be a change in the voltage. So that means here in this V is equal to IR. V is equal to IR. That means voltage is equal to the product of current and resistance, right? So here that means here the voltage, here the current is constant. Remember this point. Here the current supply is constant, and then we are changing the slider movement, thereby the resistance changes. This in turn changes the voltage. Here the current supply is constant. Remember this point. V by R. That means here the voltage is changing. That is a V proportional to R. V proportional to R. That means if the resistance changes, voltage changes. That means here the resistance changes by moving the slider on the resistance element. So thereby the resistance changes, and thereby it leads to change in the voltage. That means anybody can tell the application for this in the chat box. Application for here the current is constant. Remember this point. Current is constant. Windmill will be used, right? Windmill, right? That means in other words, we can say this potentiometer or you can also call as a rheostat. I think all of you know that rheostat. You've seen rheostat. Potentiometer in the name itself only see here potentiometer. That is in the potential. It is a potential. Potential is nothing but voltage, right? The voltage varies. The voltage here, the output voltage is varying by changing the resistance. Here the resistance changes with respect to the movement of the slider on the resistance element. Movement of the slider on the resistance element. Right. See here, that means here the current supply is constant. All of you think. Here current supply is constant. Here the voltage varies. That means to protect some device which is costly device, we can go for a potentiometer. Thereby, we can change the voltage. Like that. That means, for example, if you see, take our TV stabilizer. Stabilizer is nothing but it protect the television with high current, from high current or from low current also. That means here example I am saying example. So that means this potentiometer is used to protect any device or any element from voltage. That means wherever you can require some particular voltage, with the help of this we can supply that variation voltage. Are you understand? This is right. Here the slider movement, right? One thing is slider is displacing. Another thing is the position. Here the slider position changes, thereby the resistance is also changes, and thereby the voltage, output voltage will varies. The next, coming to the next slide. Strain gauge. Strain gauge element. This is one of the very good ones. Strain gauge. Strain gauge. All of you know that strain gauge. Strain gauge. That means it is the strain is defined. All of you know that there is a change in length to the original length. Here the strain gauge is nothing but it is a metal wire or a strip of semiconductor that is subjected to load. Subjected to load, then only the strain develops. Strain develops. That means this strain is nothing but in terms of resistance here. The resistance in terms of resistance. Here this see here this is a metal wire. This is a metal wire. This is a metal wire, right? Here the two leads are there. These are the leads. These are the two leads, right? And this one we have to connect wherever the element undergoes strain, we have to measure that strain. For example, if you see here, I will tell you one example. Here, this is a cantilever beam, right or wrong? Correct. Here, this is a cantilever beam. Here, the load is acting at one end, right? What happens when the load or force are acting at the end of the cantilever beam? It undergoes deflection, right or no? Correct. It undergoes sudden deflection, right? It by a distance, it will move by a distance x. It will move by a distance x. It will move by a distance x, right? And then see here, that means when the load is acting at the end of the cantilever beam, it undergone deflection and it moves by a distance x. I remember this point. Here the deflection taking place. Deflection taking place. That means some distance is moving. So here we have to find out the strain. Here the strain gauge we have to inserted on the top. So here when the load is acting on the beam, automatically it undergoes a strain. That undergoes strain, and this strain gauge if you connect, then there will be a change in the resistance. When the change in the resistance we can measure, actually that is a very lengthy process. That one we have to connect to the one of the resistance element of Wheatstone bridge. I think all of you know that the Wheatstone bridge, this is the Wheatstone bridge, right? This is the Wheatstone bridge, right? And then here there are four resistors are there, R1, R2, R3, R4. So like this here, this one of the strain gauge we have to connect to the one of the resistor of the Wheatstone bridge. We have to connect. Thereby what happens means there will be change in the resistance. And in the galvanometer, in the reading deflects galvanometer in the reading. This is a galvanometer. All of you know that this is a galvanometer. In this galvanometer, the reading deflects. That indicates voltage. That voltage is calibrated in terms of the displacement moved by the this one, or otherwise how much strain in the beam. These are all the calibration elements. This see here in this strain gauge, there will be a change in the resistance divided by R is proportional to the strain. Is proportional to the applied strain. That means applied voltage is proportional to that. That means, in other words, delta R by R is equal to is nothing but a strain. This is all of you know that strain. Strain is nothing but change in length by original length. Same similarly here, there is a change in the resistance divided by the original resistance. Here this is proportional. So this we have to remove the proportionality. Some G is there, that is nothing but gauge factor. G, delta R by R is equal to G epsilon. G is nothing but gauge factor. Epsilon is nothing but strain. Delta R by R is equal to G epsilon. So with the help of this one, there is a change in the resistance we can find out with the help of the Wheatstone bridge. and R is the resistance known value, and gauge factor we have to find out. From that we can find out strain. So here the strain, in terms we can calibrate how much distance it is moved like that, how much displacement. So all of you understand? Any question from this? No, Whitestone, no, Wheatstone, no, Mr. 306. What is your name? Wheatstone Bridge. I'm writing here. W. Already you studied in electrical and electronics. In intermediate also you studied. Wheat, Wheatstone Bridge. Are you clear? Number 306 letter entry. Huh? Okay, Wheatstone Bridge. Wheatstone, again I'm repeating. We will discuss in the next coming classes completely. In the fourth unit it is there. In that I will discuss the Wheatstone Bridge. See here in the Wheatstone Bridge, we can calculate the mainly when the resistance changes automatically, the galvanometer deflects. That galvanometer in turn reads the voltage, right? So the both are proportional only. What I said, the V is equal to R. That is V is equal to IR. That means V proportional to R, voltage proportional to R. Then next, this one we will discuss later. From here, what you understand words is, this strain gauge is a metallic wire of a semiconductor. It measures the strain when you place on a cantilever beam. That means the beam is under strain. We can find out how much strain is induced. What I said in the formula, delta R by R is equal to G epsilon. With the help of that, we can find out the strain. And then the strain is internal, so we can calibrate how much load we can measure and how much distance it is deflected, the calibration. All these are calculations. If you see already, you did experiment in instrumentation control system, right? Four measured device, low device. Here, add weights. When you add the weights, when you place any automatic, it displays the same place the input and the output. The display board sometimes 900 grams, maybe 1.1. That means small error is there. Like this. Here inside, what is there means here Wheatstone bridge is there. The force measurement device or load measurement device. So here the resistance changes. Already you did the experiment. Just remember it. At the one end of the cantilever, you are adding weights. Do you remember? When the college, we have to and see that load measurement device. The you are just or understand? You got the point? You got the point? Load measurement device. There, if you see in that box, the top of the box, it is written clearly Wheatstone bridge. Or you understand or not? Just message in the chat box. So now it is clear. My voice is clear to you. Number 335, lateral entry. Okay, okay. Oh, yes, clear, clear. Okay, okay, okay. Mohan Sai, okay. All right. So here, the strain gauge in the force, just you go and check in the while when the college is open, just you have to see that load measurement device. At the end of the cantilever, we are adding weights in that board only. In the top of the board, it is mentioned with the diagram, circuit diagram, and Wheatstone bridge is also there. So that means when we add the weight, automatically the beam undergoes a strain. This strain is linked to one of the resistor of the Wheatstone bridge, thereby the resistance changes. This resistance in turns uh, change the voltage. So this resistance, change in the resistance is nothing but we can find out the value strain induced in that beam. Next, we will go for the next slide. This is a capacitive transducer. This what is the time now? Somebody asked attendance, sir. What is the time now? It's 12:17. Okay, right. Just 5 minutes we will discuss, and then I will take the attendance. Right. Just 5 minutes. This another one more slide is there. Two slides. Only two slides. I will explain just. It's very simpler. This is all of you know that transducer, capacitive transducer. Here the capacitor, two plates are there, and then this capacitance transducer. That means it mainly the capacitance mainly depends on three parameters. Three parameters. What are those three parameters? Here the distance, right? Here the distance is right. Distance, distance, right? And area. Distance D means distance between the plates. A means overlap area. This overlap area. This overlap. This overlap area. This overlap area. This 1 minute. This is the overlap area, right? Overlap area and the distance. Here, if the distance between the two plates is increases, the capacitance decreases. The capacitance decreases. And here, if the area of the overlap increases, the capacitance increases. The capacitance increases. That means, and one person written that in the chat box, feeling hungry. Just 5 minutes, please bear, Babu, 369. And then here in between the two plates, dielectric, that means change in the medium. There is a change in the medium between the two plates, automatically the capacitance changes. Here the capacitance mainly depends on overlap area and the distance between the two plates, and also the medium between the two plates, that means dielectric. So here once the capacitance changes, here the capacitance changes, automatically the voltage changes. Here, why here the distance? Here the distance between the two plates changes. We can find out how much distance, how much we can get the voltage, right? So how much the area of overlap, how much voltage you are getting. That means you need that particular voltage. With the help of the capacitors, we need the required voltage, the output voltage. The next, coming to the next one. Okay, right, just 2 minutes. And then linear variable differential transformer. Linear, okay, right? I will discuss it tomorrow. This one, okay. Some of the students they are asking that we are feeling hungry, right? Okay, now the time is over. I will take the attendance. Hmm? Okay, tomorrow we will discuss this one. LVDT tomorrow. Okay, right? And then you have to respond attendance. One by one, we have to message in the chat box, my dear students. One by one. Please don't put like the 35, okay, like that. Okay, right. Just 5 minutes, please bear. 5 minutes, and then I will take the attention. Then you can take your lunch. Right? So, number one, 4, 5, 5 option, 7, 8, 8, 9, 10, 11, 12, 13, 13 fast. 14, 15, 16, 17, 18, 19, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27, 28, 29, 30, 30, 31, 32, 33, 34, 35, 36, 37, okay, right, 37%, 38, 39, 39, okay, 39, 38, okay, 39, 39 already presented, he given 39, uh, 41, 39, 40, 41, 42, okay, right, 43, okay, 44, 45, 46, 47, 47, 48, 48, 49, 50, 51, 52, 53, 54, 55, 56, 50, 60, 61, 63, 64, 65, 65, 66, 67, 68, 69, 70, 70, 70, 73, okay, right, 74, 75, 76, 77, 77, 78, 78, 79, 80, 81, 83, 83, 84, 85, 88, 88, 89, 90, 91, 92, 93, 90. Okay, lateral entry 1, 1, 2, 3, right 4, 4, 5, right 6, 6, 6, lateral to 6, right 7, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18, 19, 20, 21, 23, 24, 25, 26, 27, 28, 29, 30, 30, right, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 43, 41 option. Just 40, 41 option. Just I'm reading 38 lateral entry. Just present, given present. Yeah, just I am reading the option is just you check 322 present and the next 390 present. Okay, right, I just check not five. Five options, seven options, 8, 10, 18, 48, 55, 60, 24, 27, 39, 65, 74, 75, 77, 78, 79, 80, 80%, right? 80, 80, 80%. And later into 641. That's correct. Total 305%. Okay, correct. Again, I'm repeating all of you here 88, 88%. I given 88%. 80 also present. 41 present. Just I'm just again check it. 7, 8, 10, 18, 24, 27, 39, 48, 55, 60, 74, 75, 77, 78, 79. Later entry 6 option. These are things, right? Total members 16 members absent. Today 16 members are absent. Okay, right? All of you and some of the members they are not attempting the quiz. Today quiz I am not posted in that LMS. I will post it now. I will give the time up to the evening 6. Students, you have to write the quiz exam, right? Hmm? It's around 3 or 4 questions. 4 questions. Today's is 4 questions. It is enable up to 6 or 7. Then you can write only it will takes around 5 minutes. And then my advice to all of you, we have to listen. We have to listen concentrately the online classes. So here, don't blame the don't cheat your lectures as well as your parents. Why? Because we are putting more hopes on you, right? So I thought that all my students are listening very carefully. So we have to keep it up that one, right? Right. Thank you very much, my dear students. Thank you.